Hello friends, we have finished CNN, that is convolutional neural network. Now we are moving ahead to a different type of network which is called recurrent neural network. As the name indicates, it repeats itself. How? I will explain you. So for now, let me tell you, this is the most important and widely referred and recommended deep neural network for when there is use of sequential inputs, that is sentences or the smile string. So this is the basic structure of recurrent neural network. I am thankful to this image, so that is the edream.com for this image. So in this type of neural network which is called recurrent neural network, there is a difference compared to simpler version is that the next neuron in the hidden state or the hidden layer receives two type of input. The one is the output of the earlier hidden layer, and another one is the fresh input from the next time step. How it happens, I will explain you. It is recommended when text is to be processed. For example, when you type in Google, I want to go, would you please help? So after help, automatically you will get the ready to use input, that is me. Or for that matter, you are translating one sentence to another from language point of view. Or again, I will tell you, in Microsoft Outlook also, if you try to compose some email, and you might have noticed that it prompts you, it gives you ready to use inputs for your sentence completion. These all are based on the recurrent neural network. So it is recommended when text is to be processed. Here each node or neuron has the memory to store and process information or input received from previous layer or neuron. So as I told you, you are typing an email. Today I am ill. I am sick. I am not feeling well. So today I will not be able to come to. So after 2, it will automatically write office. So based on earlier strings, earlier tokens, earlier component or earlier words in the sentence, it recognizes, okay, office is the proper word. So among all the possible probabilities from the distribution area, it will choose the most fit word, that is office. This is how recurrent neural network is trained or works. The same is applicable to smiles also. Smiles is a way to represent molecule before before machine learning model training. So smiles stand for simplified molecular input line intersystem. It is a way to represent in one dimensional way the entire molecular structure. So suppose there is C and again C. So probability is there is either double bond or single bond type of probability. So it is sequential data. So RNN are focused artificial neural network that contains feedback loops to extract the pattern using not only the current input but also the earlier perceived input. RNN positively extract pattern from consecutive or sequential data such as text, protein sequence, that is sequence of amino acids. What type of amino acids will be arranged in a proper manner so that you will get a particular type of protein. Audio signals, speech recognition, time series, smiles, and others. So in this example, as I told you about sentence completion type of task or problem is there. So when you write it was an awesome movie, it was an awesome movie. So it means pronoun, was means verb, an means article, awesome means adjective, and movie means noun. So ultimately what is happening, it was an awesome movie. So here the RNN network remembers the earlier word, that is awesome. So it will suggest the next word based on training and based on what type of probabilities are there. What are the chances of the word movie to be placed here after awesome? This all depends on its internal memory. This memory remembers only those things, those token, those words, those part of components, those part of statements which are required. It discard or forgets unwanted information. This is the basic functioning of a recurrent neural network. So it is very much clear to you how it works now. Another example, this is the initial input multiplied by weight value. You will get this output, and this output will be fed to this next neuron. Ultimately, this all the inputs will be given to neuron of next hidden layer. So what time is it? Okay, so it will understand it may be now. Here the word noun can become. So it remembers the earlier word and this time. This is the key word. It may forget this word and this word, but time and it, so it will give now. Okay. In this way, it remembers the earlier token or earlier word and don't remember all the input data. So this is the each time fresh input is going in different step. So for example, this is step t minus 2, t minus 1, t intermediate, so and so, and t n. So each node is getting fresh input and the output of the earlier hidden layer. So this earlier output of the hidden layer and fresh input, they constitute the output of this particular neuron, and further this will go here, and in this way this training will goes on continuously. So how it happens, understand. President David was one of the most influential presidents in American history. However, David Street in California was not named after him. So two time word David is used. In the first sentence, Roosevelt, or I mean David, should be labeled as a person entity. Whereas in the second sentence, it should be labeled as a street name or a location. The first David is the name of a president, and in second, it is referring to the name of a street. So knowing this distinction is not possible without taking into account the words before them, president, and after them, street. Right? So this street is giving the logic to this David, means it is the name of a street, and this David is name of president because this president word here is important and this street is important. So RNN learn based on the neighborhood of the particular token or word. RNN for autocorrection. So to dive a little deeper into how RNN work, let us look at how they could be used for autocorrect. At a basic level, autocorrect systems take the word you have typed as input. When we type in our smartphones, it suggests us 3-4 options for correction of the typed word. Using that input, the system makes a prediction as to whether the spelling is correct or incorrect. If the word doesn't match any words in the databases or doesn't fit in the context of the sentence, the system then predicts what the correct word might be. Let's see this another example. Network. So this is C and K. So how system understands C is wrong and K will be the right option? The last token, this is the token. Token. So last token should be K and not the C. How it decides? The RNN would take in two sources of input. The first input is the letter you have typed. The second input would be the activation functions corresponding to the previous letters you typed. Let's say you wanted to type network, but by mistake you typed network C instead of K. The system takes in the activation functions of the previous letters network. So on this particular input and the current letter you have inputted C, it then shows K as the correct output for the last letter. This is just one simplified example of how RNN could work for the spelling correction. Same is possible for corrections in the Ismail's string when there is a generative type of machine learning model which generates in a de novo fashion different type of molecular structure of the drugs. Today, data scientists use RNN to do much more incredible things like drug discovery and others. Chemistry research by predicting next token or symbol in the chemical structure, and same is possible when there is the discussion regarding or the applications in terms of retro synthesis, because we all know AI not only gives you ready to use drug like structures for next stage in the drug discovery, but also it gives you the probable or the tentative route of synthesis through retrosynthesis. From generating text and captions for images to creating music and predicting stock market fluctuations, RNNs have endless potential use cases. What you expect from an RNN? From an RNN, language modeling and generating text, machine translation, speech recognition and generation, generating image descriptions, time series processing, movies and video clips processing, music classification and generation, choreography, bioinformatics, DNA, RNA, proteins, peptides, and others, chemoinformatics, Ismail's string generation. RNNs are popular architectures with high potential for natural language processing. The concept behind RNN is to apply the same function for each element of sequential data, with the output being dependent on the result of the previous step. RNN computations can be simplified using the concept of a cell. For a given step T, the cell T is the result of the previous cell T1 and the current input X. As I told you, RNN considers two types of values, the fresh input and the output of previous cell. The content of cell T will determine both the output of the current step and the impact the next cell step. This permits the network to memorize past events and model data according to previous inputs. In simpler words, at each step you have to give fresh input and output from the earlier node or neuron, and then based on different probabilities for the incoming inputs, it will decide the next output or the letter or the word or the atom or the bond or the bracket in the series. This concept indirectly assumes that the most latest events are more important than early events. For example, you are typing NETWOR. So now after R, there are more and more possibility of K, not the C. So the RNN will remember only the letter now R, and based on the R, it will suggest K after crawling all the earlier experiences, training, and the probability of most potential and promising letter, that is K. So it will remember only R, it will not remember again N. In this way, it goes on to learn and generating real genuine type of output. This concept indirectly assumes that the most latest events are more important than early events, since recent action influence the content of the cell the most. At the same time, this might not be an appropriate assumption for all data sequences. Therefore, idea of long short-term memory cell was introduced. There is no need to remember all the input and intermediates in the RNN. So there was a need for a system which can remember only required information and which will keep shedding or discarding unwanted information. Here came the role of long short-term memory. Through a more controlled flow of information, this cell type can decide which previous information to retain, that is to carry out for the next step, and which to discard, to forget or don't consider or carry. The gated recurrent unit, GRU, it is important. The gated recurrent unit is an easy implementation of the long short-term memory construction and attains much of the same effect at a reduced computational cost. All machine learning is powered by math, and math of RNN consists of hidden states, which are the hidden nodes. So the hidden states are connected to one another. In every hidden states, there are gates, which are neural network that control the transfer of information. For the hidden state to compute the information, it needs to be pre-processed and transformed into a matrix or vector representation. The hidden state of a standard or regular or vanilla RNN consists of the output from the previous hidden state, which combine with the current input to form a vector, which includes information about the current and previous inputs only, not the earlier than that one. This vector is passed through a 10H activation function, which limits the range of values between -1 to 1 and to generate the new hidden state. So here, as per this statement, in our earlier example of network, it will remember only, so it was network like it was like network. Okay, so it will remember only R and the upcoming symbol, that is C. So based on R and C, it will decide, okay, it will be not RC, it will be RK. It will not remember all this information N, E, W like this. This is the basic motto of this RNN. So what happens when training a traditional RNN is that the weight is being adjusted. We all know, to train a model, we have to continuously tweak or fine tune or edit or change weights and biases. The gradient, in case of RNN, the gradient becomes so small that it makes the updated weight immaterial. There is no effect of the training in RNN if you go for traditional way of gradient descent. So if the original weight has essentially remained unchanged, this means that there is little to no learning occurring within the model. A small gradient update doesn't lead to any significant fine tuning of the model. Here comes the role of gated recurrent unit. It has two gates, update gate and reset gate. So basically, gates are just neural network within the hidden nodes. Instead of memorizing every single word in a sentence, gated recurrent unit remembers only important phrases and words. Another example to understand this particular concept of gated recurrent unit. It remembers only keywords or important phrases which carries the complete meaning in the sentence. For example, to examine the question of how to best accelerate rare diseases research, we will review some of the challenges in rare diseases research and opportunities for therapy development that recent scientific advances are presenting. In this sentence, words like, the connecting words like to, the, of, that and for are not really relevant to the meaning of the sentence, and thus the GRU would forget those words and it will remember only the essential keywords which are giving the meaning to the sentence. To examine the question of how to best accelerate rare diseases research, we will review some of the challenges in rare diseases research and opportunities for therapy development that recent scientific advances are presenting. So had it been RNN, it would have attempted to remember the whole sentence. On the other hand, GRU only memorizes the significant terms which are underlined here, that is, accelerate rare diseases research, which is a challenge, and we have to go for therapy development. These are the important words which summarize entire sentence essence or the meaning. So what is the role of update gate? The update gate's role is to decide how much of the information from the preceding hidden states needs to be kept. Vanishing gradient descent problem is solved by passing through this gate, since the model gets to decide how much of the past information it needs to pass to the future hidden states. Reset gate. The output from the previous hidden state and the current input combine to form a vector, which includes information about the current input and the previous input. Each vector has not only information in the current hidden state but also previous hidden layer. Reset gate is known for deciding what past information should the model forget. Mainly, the function of this gate is opposite to that of the update gate. In case of update gate, it works by remembering few things. Here in case of reset gate, it should forget what is not required. In this situation, the input of GRU or the decoder is a vector representing the compressed form or latent space representation of the molecule. So one beautiful presentation, I mean the video I came across around 5 to 6 months, and it was the video by Michael Gill, senior data scientist at world famous AI driven AI company which is using AI driven technologies for drug discovery. The name is Benevolent AI. So here, predict probability of next word in a sentence. Chemistry is amazing, difficult, potato, compare. So obviously, depending on the training or earlier data sets or probability distribution, it will choose the word difficult or something like that. So language model for chemistry. So here it is like you understand it like a sequence of letter or the words. So again, based on the probability what will come after this carbon and double bond, it will give the probability of the particular option. So here also the task is predict the probability of next character. So presently most of the generative models which are used for de novo drug designing, there is use of recurrent neural network. After training your RNN on hundreds of lakhs of drug like molecule, then model understand the basic grammar or the rules for different types of bonds, atoms and other things based on the rules of chemistry. So based on the training, it would suggest you what should be the next character, same like network spelling we have seen earlier. So very beautiful paper I came across, molecular de novo design through deep reinforcement learning. So if you want to understand how RNN is being used across the world in pharma or AI industry, engaged in drug discovery through AI driven technology, you should read this article. They have very beautifully summarized how this is done. So again, this is the cell T1, cell T2, T3, T4. This output will be used as input for cell T2 along with fresh input. So the input for this will be based on the output of this one and so on. RNA's internal memory capacity indicates its ability to remember previous information within the network to assist it make decision. So another very beautiful illustration, meaning is same, input will be fresh for each step along with input from the output of earlier hidden layer. So in this way you understand here, network is a character level LSTM, long short term memory with initial embedding layer and teacher forcing, trained with Ismail representation of compounds from database. So this is the symbols we want. Now this is the input C, this will be the output, this will go here, it will give output, it will go here. In this way it will go continuously until you get a perfectly chemically valid Ismail string. This is the example of use of RNA in generating or understanding molecule. So here again, how it works, you have database of compounds, say for example PubChem or Chembel or Zinc or DrugBank. Using this type of databases, you will train your RNN model so that model will learn the basic rules of chemistry and probability of what will come before or after each atom or bond based on type of atom or type of bond. Then you will generate a latent space, and this from latent space, this is latent space which is a set of similar molecules will be put together in the latent space, and when you will pick a random sample from latent space, you will get a new compound, probably which will be similar to or somewhat identical to the training sample data set. So this is another, this is the set of generated molecules. And now we are going to conclude with another example. So you have the chemical structure, that is molecule, and it is in the fashion of molecular graph, and this is changed into a smile pattern, and you will train the RNN model, and after that model will learn to make the various type of smiles or the molecule. This is the starting token. Here you have to begin. It will give C. This will go here. It will give you output. Okay, after C, there is chances of O. After O, chances of C. Likewise, you will give the N token. So between start token and end token, it will go on continuously to generate a molecule which is probable, which is perfect from viewpoint of chemical, the chemistry rules. It should be a valid type of molecule. Here in this example, now we are seeing how RNN is used to generate different type of unique molecules based on the training of RNN. Ultimately, the use of generative type of deep learning model is to generate some novel drug-like molecule or drug-like structure. If we talk about drug discovery, if we are in some another industry, there might be the role to produce more and more images which are similar or improved version of the improved version of the training data set. So here you are training the model, and from this model you are getting the log p value. So you will this is your training data set, this is your model, and model will give you the latent space. From latent space you will pick out one particular sample, and you will check its log p value. If it is okay, you will stop sampling. If it is not okay, two options are there. You will tweak or fine tune the activity by changing the vector, or you will change the sample picking from another area, and you will get log p. Ultimately you will get a valid structure. This is how you have to use the trained RNN model to generate more drug like molecules or more input training data like molecule. So before we conclude, we will discuss in detail about the example of RNN from a paper I have come across already. We have shared the reference earlier. So there are total 5 diagrams: A, B, C, D, and E. First, we will talk about A. This is summary of entire video. A, B depict the multi-layer perceptron, that is simply artificial neural network with one hidden layer. This is input layer, output layer, and hidden layer, right, side by side for comparison. Here the input layer X containing the input feature, the hidden layer H, and the output layer O represent vectors with multiple units, right. Subpanel C, this is C. It depicts the RNN in its unfolded representation. In contrast to an MLP, the hidden layer of an RNN receives its input from both the input layer and the hidden layer of previous time step, that is t minus 1, if the current is t. Now we will talk about this D as per our pharmacy knowledge. Illustration of the RNN training process. Input molecules are converted into a sequence representation. This is your input molecule. So it can be called an image, or it can be called a molecular graph. So for image or molecular graph, we have the only option of CNN or convolutional graph. But for RNN, we have to change it into 1D, that is Ismail string. This is Ismail string. This is the start token. It is end token. Otherwise, it will keep generating more and more molecule. So illustration of the RNN training process. Input molecules are converted into a sequence representation, which is divided into tokens. This is one token, token 2, bracket symbol, double bond symbol. Each indicates one token. At each time step, The RNN receive, this is time step, t minus 1, t plus 1, and so on. They are called time step. At each time step, what happens? At each time step, the RNN receives one token and returns a probability distribution over all the possible token type. Means as soon as you will give the C, it will show various type of possibilities what will come after this C. This is called the probability distribution over all possible token types. How it learn? It has learn probability distribution based on your training through thousands of lakhs of data while training the RNN type of deep learning model. The RNN is trained such that the probability corresponding to the next token in the sequence is maximized. Now E, to synthesize new molecule after training, that is to generate new molecule from a trained RNN, a token is randomly sampled from the probability distribution. If you remember, just we have finished those picking up of the samples. A token is randomly sampled from the probability distribution at each time step. Tokens with a higher probability are more likely to be drawn. The sampled token is then provided as input at the next time step. When the network outputs an N token, the sampling is terminated. The generated Smiles string can then be used as a template for synthesizing the new molecule. So with this, we finish two important deep neural network like CNN and RNN. So CNN employ filter within convolutional layer to transform data, whereas RNN reuse activation functions, same activation function from other data points in the sequence to generate a next output in the series in a valid fashion. With this, we conclude this another video. Thank you very much.